All right, my dear, I'm going to walk you through this problem because you actually made a little bit of an error up here in the numerator when you were applying quotient rule. So remember that quotient rule says that if you have a quotient and you're taking the derivative, dy over dx, you take the denominator. Here, I'm just writing the general rule first, actually. So if we have f of x over g of x as our function, then you take the denominator and multiply it by the derivative of the numerator, subtract the numerator, and then multiply by the derivative of the denominator, and put that all over the denominator squared. And because subtraction is not commutative, you can't switch around the products in the numerator. It has to be, you bring up the denominator first and multiply it by the derivative of the numerator. Okay, so let's start this fresh. So we can see which is the numerator and which is the denominator, right? So dy over dx will be equal to the denominator, x plus 1 cubed, times the derivative of the numerator, which we need to use chain rule to find the derivative of the numerator. So I'm going to use brackets just to organize my work. So thinking chain rule, we have 3 times the quantity, x squared plus 1, now squared, times the derivative of the inside, which would just be 2x. Okay, then we're subtracting the numerator and multiplying by the derivative of the denominator, which we again need to use chain rule for. So 3 times the quantity, x plus 1 squared, times 1, all over the denominator, x plus 1 cubed, squared. Okay, so let's clean up the numerator a little bit. I'm going to pull a 6x out front, and then I have x plus 1 cubed times x squared plus 1 squared minus 3 times x squared plus 1 cubed times x plus 1 squared. And that's going to be all over x plus 1 raised to the 6th power. Yeah, you had a 2 here too. Okay, starting fresh, so we're here. Okay, so now we can see that we have in the numerator a product minus a product. And in the denominator, we have x plus 1 raised to the 6th power. Well, we have x plus 1 cubed and x plus 1 squared, which we can factor out so that we can then cancel the quantity x plus 1 raised to the 2nd power with an x plus 1 raised to the 2nd power in the denominator. So we can pull that out, but there's also more that we can factor out, right? The GCF of 6x and 3 is going to be 3, so we can pull 3 out. And then the GCF of the quantity x squared plus 1 squared and x squared plus 1 cubed is going to be x squared plus 1 squared. So let's factor out everything that we can. Okay, so 3 times x plus 1 squared times x squared plus 1 squared. And then we're left with, and to figure out what we're left, this remaining factor is, we can think about either dividing each of the products by what we just factored out, or going, okay, well, what times 3 times the quantity x plus 1 squared times quantity x squared plus 1 squared would give us this first product up here? And the answer would be 2x times the quantity x plus 1. And then to get the second product here, we would have to multiply this product by, not a 3, so we would have to multiply by x squared plus 1, the quantity x squared plus 1. And this is all over the quantity x plus 1 raised to the 6th power. Okay, so let's clean up this last factor over here. And also notice that we can cancel an x plus 1 squared. So the reason that we are able to cancel an x plus 1 squared in the numerator and denominator is because in the numerator we have a product, right? We have 3 times the quantity x plus 1 squared times the quantity x squared plus 1 squared times that quantity, okay? So because we have a product and no longer just a difference of 2 products, we are allowed to cancel out that x plus 1 squared from the numerator and denominator. So let's finish simplifying this. So we have 3 times the quantity x squared plus 1 squared, and that'll be 2x squared plus 2x minus x squared minus 1. And now we have in the denominator the quantity x plus 1 raised to the 4th power. Now notice that we have like terms that we can combine here. So I guess I'll write one more line. So we'll have equals to 3 times the quantity x squared plus 1 squared times x squared plus 2x minus 1 all over the quantity x plus 1 raised to the 4th power. And I believe that that's the answer that I had in my solutions. Let's double check though. So our practice test. Yes, that's the answer that I had in my solutions. So I hope this helped. Let me know if you need any more clarification or if I need to explain that in a little different way.